Hello everyone, welcome to my YouTube channel Shivam Ports. Today I will be talking about the rsync utility in Linux. So rsync is basically a command line utility that helps us sync files between two computers. So rsync, which basically stands for remote sync, it is a command line utility in Linux for efficiently copying, backing up, and synchronizing files and directories either locally or remotely over SSH. Mostly you will be using rsync for remote syncing of your files, but you can also use it for syncing your files locally. But generally, people prefer other methods of syncing their files locally. To sync your files locally, I generally prefer mv and cp commands over rsync. Rsync could be an overkill. So if you're not aware what mv and cp commands are, you can check out the mv and cp command from the I button. So I'll just give you a quick recap. mv command, which basically stands for move, is used to cut paste your files in Linux. The cp command, which basically stands for copy, is used to copy paste files and folders in Linux. And rsync command, which basically stands for remote sync, can also be used for syncing up your files remotely, but I generally prefer it when I have to do a remote syncing of my files, which is between two computers. Moving on, let's say I have a local system. So at the moment where I'm recording this video, it is on a laptop, and this will be my local system in our example. So let's say in my local system, I have some folders and files. I have a data folder, images folder, and some random files. Let's say I also have a remote system, and now I want to sync the files between my local system and my remote system. So one way to do is to use rsync, which is remote sync. Now I will be using the rsync utility to sync the files between my local system and remote system. So my remote system will also have these files. So here on the left hand side, this is my local system. So if I do an ls, these are some of the files which I have created in my YouTube directory. And at the moment, this is also my local system. So now what I have to do is I have to log in to a remote system, and I will be doing that using SSH. If you're not sure how SSH works, let me know down in the comments and I'll create one video in the future explaining how SSH works and its nitty-gritty. So now to SSH into any computer, all you have to do is first you have to write the SSH, and also you should have SSH installed on your system. But if you have bought the system in the last 5 to 10 years, I don't think you have to install SSH. It will be pre-installed on your system. So now what you have to do is you have to mention the username on that remote system. So let's say you can have multiple users using that system. So I have to specify the username. So the username in my system is Shivam Pai. And now I have to mention the IP address of this server which I want to log into, or that computer which I want to log into. So I'm aware of the IP address since I have allocated my Raspberry Pi a static IP address, which is 192.168.0.100. Now, if you're not sure how to assign a static IP address, don't worry. I will just quickly explain you how you can do that. So all you have to do is you have to navigate to your network, then your Wi-Fi if you are on a Mac. If you're on Windows, you can figure it out how you can figure out the IP address of your system. And then you can go to your details. Here you can see the IP address of my current system, which is 192.168.0.8. And you can also see the router IP address, which will always end with 1. Now all you have to do is you have to paste that IP address on any browser, and then you will be routed to a page where you will be asked to enter the username and password. If you're not sure what your username and password are, then you can check your router. The username and password are usually mentioned in your router. And if not, then you should connect with your internet service provider, because sometimes what can happen is the internet service provider doesn't want you to change these things. If that is the case, then you can't assign any static IP address. But if you have the access, if you are aware of the username and password, just go ahead and check out your Wi-Fi router and you should be able to find that username and password. Just log into it and try to play around and you will learn of how you can assign a static IP to any device. Okay, so now that you are aware how you can assign a static IP address, so I have a Raspberry Pi which has this static IP address and I'm SSHing into that box. So it will ask me for password. Just enter my password. By the way, this thing at the bottom which you are seeing, I've basically written a small script which shows the temperature of my Raspberry Pi at the moment and it is refreshing every second. So it is just the temperature of my Raspberry Pi, nothing else. So now this is my remote system which I have logged into. Yep. So, okay. Now let's say I have these files which I have locally on my system and okay, and I want to sync these files and I want to send these files basically to my remote server, which is on the right side. So left side is my local system, right side is my remote system, which is Raspberry Pi, which I've logged into. So now I want to send these files to my Raspberry Pi, which is basically syncing my local system with the remote system. And by the way, my local system and remote system are on the same Wi-Fi network. As you already have seen the IP address. So the local system IP address is 192.168.0.8 and my Raspberry Pi IP address is 192.168.0.100. So they are basically on the same network. I just wanted to point that out. So now how do we use rsync? So the basic syntax of using rsync is we type rsync and then we will have to mention some flags which are which can be anything. We'll go over it once. And then we have to mention the source and destination. Destination. So this is how usually the rsync command would look like. So we will use the rsync keyword. We will mention some flags and we will mention the source and our destination. So in our example, the source will be my local system and the destination will be my Raspberry Pi. So let's go over it. Let's use the AV flag and another progress. Okay. So I've used two flags. Don't worry. I will be explaining you what these flags are in a minute. Now we have to mention the source. So the source is tilde, which is my home, then data and YouTube. Okay. This is my source. From here, I want to transfer my files to a remote system. So now how will I mention my remote system, which is nothing but it is very similar to how we SSH'd into my remote system. So I'll mention the username, which is Shivam Pai, and then at the rate the IP address 192.168.0.100. And then inside this system, where should I be storing it? So we have to mention a colon. You just expand this a bit. We have to mention colon, and then we have to mention the place where that file has to be dropped. So tilde slash, and it has to go in data. So all I'm doing is I'm taking the contents of this YouTube folder and I'm putting it in the data folder. And I will be using one special flag, which is dry run. So what this will do is this will not actually copy paste the contents from my local to remote, but it will show me what all will be copied because I'm running this as a dry run. So now let's run it to give the password of my remote system. So here it showed me what all will be sent. So it will be sending the whole YouTube folder, it seems. and all the contents inside the YouTube folder. But at the moment, if I do ls, those files and folders are not here because I had used the dry run flag. Whenever you use dry run flag, it will only show you what will be transferred, but nothing will be transferred. So it is a good check to have this dry run flag. And this progress flag, basically, it shows the progress status of how much data has already been sent. It is something good to have. It doesn't give us any benefit while transferring files or anything. Now on this AV flag. So let's check out the man page about this A and V flag. So since my Raspberry Pi runs Ubuntu, so I will be checking the man page here. Okay, since this man page is pretty huge, it is better to store the contents of this man page in another file. Let's name it man rsync.txt, and we can use vim to navigate in this file. Okay. I just set it the numbers. Okay. Now all I have to do is we can use so that V flag basically stands for verbose. It will give us more information when we use the verbose flag. So the next flag was the A flag, which basically stands for archive. Here is our archive flag. Archive mode is, so this archive flag basically is a combination of multiple flags, which is this R flag, L flag, P flag, T, G, O, and capital D flag. Now I'm not sure what all these flags do. So this man page will have definition of each and every flag. If you are interested, you can go ahead and check out the man page for all these flags that are mentioned here. But instead of using all these flags, you can simply use the -a, which will include all of these things. So the man page for this is very huge. If I go to the end of the file, it's about 4K lines. But I'll show you one more thing, which is what archive does. So here it is. So this archive flag is equivalent to R, L, P, T, G, O, and capital D, which I have already mentioned. It is a quick way of saying you want recursion, which is basically in the R flag. So you basically want recursion and want to preserve almost everything. Be aware that it does not include preserving ACLs. Okay. Okay, so yeah, you can check out the man page for more information. I'll be using the archive flag. Okay, let's quit Vim. So now earlier we had dry run to just see what all will be sent it from our local system to the remote system. Now, all I will be doing is I will be removing the dry run flag. By the way, I should also show you what this dry run flag does. So let's dry run. So this will perform a trial run and does not make any changes. So yeah, you use dry run for having a trial run, and it will not actually go and copy paste your files or sync your files between the systems. Yeah, man page will always be your friend. If you have any questions, go and check out the man page. So now I have removed the dry run flag, and now I will be running this command to sync the files between my local and remote system. So at the moment, if you will see, I only have three things in my data folder, which is a Linux 6.8 directory, an OS directory, and a file that we have just created. So now let's try to send these files over the network to my remote system. Let's enter the password. So it has transferred all the files. If we check the remote system, we have the YouTube folder here. Let's navigate to this YouTube folder and let's do an ls. So all the contents that were there on my local system are now being sent it over to my remote system. So basically, my remote system and local system are now in sync. They both have the same contents. So all the files were transferred. There were total these many bytes sent, few bytes were received. This was the speed. So it is mentioning everything in bytes. And this was the total size which was sent it over the network. So this is how an rsync command can be used to sync files between systems. So now as we saw in the terminal, how we were able to sync our local system and the remote system. So under the hood, rsync is playing very smartly. And I will be explaining you how it is doing that. So basically, when I run the rsync command, what it will do is it will create a metadata in the remote system first. So let's say I have data folder, images folder, backup.txt, readme.md, and requirements.txt files. So two folders and three files. So what rsync will do is it will first go in the entire folder, which was YouTube folder in our example, which I showed you in the terminal earlier. So what it will do is it will copy only the name of the files and folders and some metadata corresponding to it. And it will store that in the remote system. Then all it will do is it will start copying the files and folders from remote system to the local system. And now both the systems will be in sync. Now you might be thinking, how was that smart? I mean, what was so smart that rsync did when it created a metadata? So I will be explaining that. So let's say on my local system, I created a new folder, which is I'm naming it as new folder here. And now if I want to sync the files between my local system and remote system, so the rsync is smart since it already has the metadata and it knows what information it had synced earlier. So it will only sync the new files and folders that were added. And that is known as the delta transfer algorithm, which rsync uses. Now this algorithm is basically smart enough to recognize that, okay, only one folder was added, which was new folder. So it only has to sync that folder in the remote system, and rest all of the files and folders remains as it is. So one of the algorithm that rsync uses is the delta transfer algorithm, which I just showed you. Now let's say there was another file that was changed by the user. So nothing new was added, but one file was changed. Some content of the file was changed. So now how rsync handles this is it stores two information, which are last modified time and the size of the file. In our example, both of these things will change. Last modified time will also change since the user has changed something in this file, and also the size of the file might change. It might not change as well. Since the last modified time was changed, rsync, when it is checking the metadata, it must have stored the size of the file and the last modified time. And since during this sync up, the requirements.txt last modified time is different, it will sync the contents of requirements.txt into the remote system. Now I'll show you this in action. So here, left side, I have my local system, and on the right side, I have my Raspberry Pi. So let's create another file here. I'll create using the touch command. So let's call it new file.txt. And let's write something to this new file. Okay, so I have written these contents. I will be saving the file and I will quit the file. So now if I cat, this new file has the contents which I have just written. Now let's try to sync my local system with the remote system. Oops. So on the right hand side, I have these 7 files. Let's try to sync them. So we will use the rsync command, then the AV flag. Let's use the progress flag as well. And I will be transferring files from my data YouTube folder, and my remote system is having the username of Shivam Pai, and the IP address is with an @192.168.0.100. And now I have to specify a colon. Then I will mention the path where the file has to go in remote system. First, I generally prefer to use dry run to see what all files will be going, because I don't want to send random files. So here you must be noticing that there are total 10 files, but there is only one file that is changed and only one folder metadata is changed. Hence, it is also trying to send this folder. So rsync is smart enough to analyze that, hey, there is only one file that was added. Let's not sync up all the files. That will be waste of time and waste of resources on the system. Let's only sync up that one file that was changed. And this is the delta transfer algorithm that I was talking about earlier. So now let's remove the dry run flag and let's try to send the files and sync our local and remote system. Enter the password. So let's see that. Yeah, we have the new file.txt being created, and let's cat the contents of this file, and it has what I had written in my local system. So now I have one question. What will happen if I resync the files between my local and remote system now? Since they are already in sync, what do you think will happen? Let me know in the comments what you think should happen. Okay, so let's try to resync the system now. So the local system and remote system were already in sync. Let's do it again. So there was nothing to sync, but still some few bytes were shared. So this 466 bytes that you're seeing is nothing but the protocol overhead that we will always have. So even if I try to resync my files, then I will be having those bytes. Yeah. So even though we have no data to send, this is just the protocol overhead that you're seeing. So what we learned two things, which is rsync uses delta transfer algorithm to only transfer the changes that were made and sync the two systems. And how rsync does, which is it stores two things. First is it stores the last modified time and also the size of the file. If any of these changes, it will sync that file. rsync also comes with a lot of more benefits. You can check out the man page for it. Any Linux utility that you will find, the best resource for it will be to check out the man page. So in the terminal, now we actually saw how the delta transfer algorithm works. And if there is nothing to sync between the two systems, we only saw the protocol overhead and no file was transferred. This is the power of rsync. Rsync is majorly used when you are dealing with a file system and you have to take some backup or you want to sync the files at two locations. So that is it for the video, guys. I hope you liked the content. If you did, make sure to like, share, and subscribe, and I will see you in the next one.